Hi, today we'll discuss LeetCode problems number 5, longest palindromic substring. Given a string S, return the longest palindromic substring in S. A palindrome is a sequence of characters which reads the same backward as forward. For example, A, B, A. So this question asks you to find the substring in the given string, and the substring is a palindrome. For example, in the given string, BAB is a palindrome. The length of this palindrome is 3. There's another palindrome substring is ABA. The length is also 3. So the longest palindromic substring is BAB, or it's ABA. Today we'll discuss in detail how to solve this problem with a Moniker algorithm. Which gives big O n time complexity. We'll learn what is the common sense in a Moniker algorithm, but before we get into Moniker algorithm, we'll still spend some time to discuss the approach, which is more obvious and intuitive. Then we will evolve our solution with a Moniker algorithm. Let's look at the examples in the problem. In the first example, the palindrome we found is ABA or BAB. As we can see here, this palindrome has a center in the middle. It's B. The characters on the right side equal to the character on the left side, and the length is 3, which is odd number. In the example number 2, the palindrome substring is BB. And different from the example number 1, BB together is the center of the palindrome. And the length is even. In the example number 3, there's only one character A in the string. The palindrome is A. So from this example, we can see that each character itself is a palindrome. And in the number 4, we have two characters in the string and they are different. The palindrome in the example number 4 is either A or C. The size is 1. And in the example 3, the length is 1. So we're going to write down the characteristics of the palindrome. From the examples provided in this problem, we can have the following characteristics of the palindrome. First, each character itself is a palindrome of size 1. And 2, the palindrome has a center and the left side and the right side mirror to each other. And 3, the center can be a single character or twin of characters. For example, we have a string B, A, B, A, D. So for us to find the palindrome with the maximum length, we can choose a character in the string. For example, we can start with B. And we try to compare the characters on the right side with the character on the left side. If they are equal, then we will expand our palindrome from the center. But in this case, there's no character on the left side. So the palindrome with the center B is just B itself. It's a size of 1. Then we can continue the same process for each character in the string. In this case, when we examine the second character A, we compare the character on the right side with the character on the left side. They are equal. So we expand the palindrome to BAB. Then we will try to see if we can extend the palindrome to the letter A. But on the left side, there's no character on this same position. So our process stops here, and the palindrome we found is BAB, is the size of 3. We keep the same process until the end of the string. So in this example, we'll return the palindrome BAB. So we just gave the example for the single center palindrome. And for the twin center palindrome, the process is the same. For example, in the example number 2, we have. So in the single center palindrome, we extend the palindrome from a single character. But in the twin center, we expand the palindrome from the 2 characters in the middle. When we check if we can extend from this center, we need to compare the D from the right side with the C on the left side. Here's a pseudocode. First, we'll have a for loop to visit each character in the string. Here, we visit each character in the string. We're going to use this character as the center of the palindrome. Inside of the for loop, we'll try to expand from the character at position I. So our first step is extend palindrome from I. Char at I. So this line of code is for single center. And the next, we also need to find a palindrome for the twin center. So we extend palindrome from char at I and char at I plus 1. And this is for the twin center. For example, if we have a string like so in this example, not only we will find the palindrome with the center B, we also try to find the palindrome ABBA, which has a twin center. And after we get our palindromes, we will see if the new palindrome we got has a longer length than the palindromes previously found. So we'll keep track of the maximum length. So we create a variable called max to keep track of the maximum length of the palindrome. We also keep track of the starting position of the palindrome. We call it left. So this is the starting position. if palindrome with a longer length is found, we will update the max. We also update the left. Okay, so these are the steps in the for loop to find the palindrome with the longest length. Now at the end of our function, we are going to return the palindrome. We're going to use a substring, and the first parameter is the starting position, which is left. And the second parameter is the right position, which is left plus max. Okay, let's check the pseudocode with an example. For example, we have a string. Let's try to find a palindrome with the longest length from this string. So here we will keep a table. In the table, we're going to have I and I plus 1. I is used for a single center. I and I plus 1 are used for the twin center. And also we keep track of the max left. So in the beginning of our loop, we will extend the palindrome from the single center and I equal to 0. We don't need I plus 1 because it's a single center. Default value for max is 0. And the default value for left is 0. So we try to extend from A, but there's no character on the left side. The length of the palindrome is the character itself, so it's 1. Then we'll try to extend the palindrome from the twin center. I is 0 and I plus 1 is 1. And first we will check if the characters at these two positions are equal. A and B are not equal. So we don't have a new palindrome. Our max remains as 1 and the left remains as 0. So next we move the index to the next position. It's 1. And we don't need I plus 1. So we try to extend from the single center B. The character on the right is A equal to the character on the left A. So we have a new palindrome with a length of 3. We cannot extend palindrome anymore because we don't have any character on the left side to compare with the B at position 3. So our new max is 3. It was 1. Now it's 3. And we will update the left index. It was 0. And because our new palindrome ABA starts from 0, so we don't have to update left. And the next step is we try to expand from 2 characters, from 1 and 2. First we will compare if B equal to A. So they are not equal. Max remains as 3, left remains as 0. Then we move our index to the next position. Our I equal to 2. So max is 3, left is 0. We expand from A, then we found a palindrome BAB. The length of this new palindrome remains 3, so we don't update the max and the left. So for the double, we will have 2 and 3. Now A doesn't equal to B, so our max remains the same. Then we move the index to the next position, 3. Now I equal to 3. The current max is 3, and the current left is 0. So at the position 3, with a single center B, we cannot extend. So the length of our new palindrome is 1. So we just ignore 1 because our max is bigger than our new length. I equal to 3. The next character is 4. And the current max is 3. The current left is 0. First, we'll compare if these two characters are equal. If they are equal, then we will have a twin center. Then we'll try to expand from position 3 and 4. The character at position 3 is B, and the character on the position 4 is also B, so we find a twin center. Now next, we try to expand from B and B. Now we found a new palindrome ABBA. So we will update the max with 4. And this new palindrome starts at position 2. And we update the left with 2. Then we move the index to the next one. And we cannot expand from B. Then we move to the end of the string, it's A, and we cannot expand from A. Once we exit the for loop, then we will return the substring. Our substring is from 2, so the end index is left plus max. So we are going to return substring as 2, 6. So as you notice, the last position is actually at position 5, but we are passing 6 is because of the end position is excluded from the substring. Okay, next we are going to the LeetCode website to implement the code based on our pseudocode. Here's the pseudocode I prepared in the LeetCode website. First, we need to declare some variables. We declare an integer left to keep track of the starting point of longest palindrome, and the integer max to keep track of the longest length. The length, we use this variable to get length of the current palindrome. We need a for loop to visit each character in the string. And the index is I, the starting position is 0. The first step in the for loop is to extend the palindrome from I for the single center palindrome. For this step, I create a function called extend from center. This function will take 3 parameters. The first parameter is a string, and the second parameter left, and third parameter right. So left and the right are used as indices of the center. For single center, the left equal to the right. And for double center, the right is equal to left plus 1. For example, for the single center, left and the right both are equal to 3. And for the double center, left equal to 3 and the right equal to 4. So inside of this extend from center function, it checks if the character on the left side equal to the character on the right side. And also make sure the left index is greater or equal to 0. The right index does not exceed the length of the string. If it meets all these conditions, then we extend our palindrome on both sides by decrease the left index by 1 and increase the right index by 1. Once we found our new palindrome, we'll return the length of the palindrome. So the formula of the length of the palindrome is the right index minus the left index and minus 1. So here we'll call the function extend from the center. And we will pass the string. We pass the center, which is I. We pass the same value for the right index. The next step, we call the same function to check for the double center. And the way we pass it is I as the left index and the I plus 1 as the right index. This function returns the integer, which is the length of the palindrome. When we call this function, we will save the length to len. When we call this again, we will compare the length from the single center with the length of the palindrome from the double centers. We're going to use the max function from the math library. So len equal to math.max. And from the previous step, the len is assigned to the length of the single center palindrome. And here we compare the length of the single center palindrome with the length of a double center palindrome, and we get a maximum. Next, we're gonna check if the length of the palindrome is longer than the maximum length already found. We're going to have the if statement. We check if len is greater than the max. If the new length is greater than the max, then we will update the max. Max equal to len. And we also update the left index. Index for the left is equal to I minus the len minus 1 divided by 2. Okay, so the len is the length of the whole palindrome, and we divide the length by 2. It gives you half size of the palindrome, which is the distance from the left to the center. For example, we have a string A, B, A. So the index is 102. So our center is here. So the len is equal to 3. And this is the left index. To get value for the left index, here is I. We need to use the index from the center minus the distance between the center and the left index. Len minus 1 divided by 2, it gives you the distance from the center to the left. Then we use I minus distance, we will get the index for the left. Okay, for example, the len is 3 minus 1 and divided by 2, I is 1. So here is 2 divided by 2, 1 minus 2 divided by 2 is equal to 0. 0 is the value for the left index. Come back to the LeetCode. So at the end, we're gonna return the substring. Okay, this is the implementation based on our pseudo code. Let's test it. We passed the test. Let's submit our code. So it passed the submission. The runtime is 23 milliseconds and is faster than 92% of all the online submissions. The time complexity of our implementation is big O n squared because we have one for loop to visit each character in the string, and inside of the for loop, we use a while loop to extend the palindrome. is big O n squared. And as we submit our code in the LeetCode website, the runtime is 23 milliseconds. And it's faster than 92% of all the online submissions. Okay, next we'll talk about an algorithm. It's called a Moniker. Gives big O(n) as runtime. The problem with the solution we just discussed is that it always tries to extend from each character in the string. For example, we have a string here. If we find a longest palindrome in this string which is centered at D, it will be from A to A. And it has a length of 9. And next, we'll move the pointer to the next character. Right now it's B, it doesn't go anywhere. Then it moves to next character, and it's C. And here, it tries to expand from C. But we know that from the C, we can only expand from B to B, and it doesn't go anywhere anymore. Now, how do we know from C we can only expand from B to B? Is because one of the characteristics of a palindrome is for each character on the right side has a mirrored character on the left side. And the character on both sides has equal distance to the center. Our center is here. Right? This is the longest palindrome. If there is a palindrome exist around the same character, C, and the same palindrome also exists on the right side. So we know that if we expand from C, we cannot go beyond the length of 3. But our algorithm always tries to expand from every character, so there are a lot of steps are unnecessary. If we can eliminate the steps which try to extend within the boundary of a larger palindrome, then our solution will be optimized. That's where Moniker algorithm comes to play. The Moniker algorithm works as following. First, it tries to avoid from the characters which can't extend outside of the boundaries. What do I mean by this is that, for example, we have a boundary created by the center D. And when we look at the character, we know that the length of the palindrome it will create at maximum is 3. So we don't try to extend from the letter C because it's totally contained by the boundary created by the letter D. Then we will quickly move to the next character if we know that it's contained. And next, it will use the property of mirror the palindrome within the boundaries. This means at the center D, there's a palindrome found on the left side of the center D, and it's within the boundary, there must exist the same palindrome on the right side of the center D. When we come to the letter C, because of this property, so we know immediately the length of the palindrome from the letter C will be 3. And the third, it will keep track of the length of the palindrome for each character visited. Come to this example again. The reason we know it has a length of 3 is because we already visited the mirrored character on the left side. It has the length of 3. So when we move from character to character along the string, we can keep track of the length of the palindrome for each character. Then we will use the value later for the new character we're visiting. In this example, we have 1 and A is 1, B is 1, C is 3, B is 1, and D is 9. Our center is here. All the characters B, C, B, they are contained in the boundary, so we know that this one is 1, and for C is 3, and for B is 1. And this technique is called dynamic programming. Let's create a pseudocode for the Moniker algorithm. First, we will declare an integer array to keep track of the length of each palindrome. We call it len. Then we need integer variable to keep track of the center. This is the center of the palindrome, which can reach to the most right boundary. And then we need an integer variable called right. This variable keeps track of farthest right position of the palindrome. Algorithm will be like this. For each character in the string, we're going to use a for loop. Inside of this loop, the first thing we will do is to compare the position I with the boundary of the current center. So when we compare the I with the right boundary, there are three scenarios. The first scenario is I is greater than right. It means it's outside of the boundary. This is the case of the letter E here. If we are visiting the letter E, E is outside the boundary defined by the letter D. So in this case, we'll initialize the length equal to 1. Remember, each character itself is a palindrome of size 1. And the second scenario, the mirrored palindrome is contained. For example, at the letter C, the mirrored palindrome is here, and is totally contained within the boundary. That implies that at the current letter C, the palindrome we can find is also contained within the boundary. In this case, we will assign the initial length to the length of the mirrored character. And the formula is like this: 2 times center minus I. Let me explain to you where does this formula come from. So our I is here, and here is the center. So if we use I minus center, it gives the distance from I to the center. So here is the distance. Then, if we use center minus the distance from the center, it will give us the position to the mirrored character. Remember, the distance from the center for the mirrored characters are equal. So if here is a D and here is also D, this formula gives 2 times center minus I. The third scenario is if the palindrome we can find is partially contained by the boundary.
Let me explain the scenario number 3 with an example. Let's say we have a string. When we try to search the longest palindrome, let's say we found the palindrome centered at D and is bounded from A to A. And before that, we have another palindrome. It centers at C, is bounded from B to B. As you can see that the palindrome at center C is partially contained. So when we visit the C on the right side and we try to copy the length of the palindrome from the left side, so the length here is 5. But we cannot copy 5 to C is because if it's 5, we have an unknown character here. Right? We don't know what it is, but we know the fact that it doesn't equal to B. If it is B, then the palindrome we found here can be extended further. So at C, the existing palindrome is from A to A. It is the part inside of the boundary. So the length is not 5, so it's 3. So in the scenario number 3, we're going to assign the length as such, equal to the length of the palindrome inside of the boundary. After we initialize the length at the position I, our next step is try to extend the palindrome. From the next character. What do I mean is, at C, we assign 3 to the center C. So the initial palindrome is ACA. Now, when we try to extend we try to extend from the character next to it. After the extension, we will check if the length of the new palindrome grows outside the boundary. If we can extend from C to outside of the boundary, in this example, it doesn't go anywhere. But if we can, then we have to shift our center and the boundary on the right side. Shift the center to I. We also need to update the boundary right on the right side. Then we also need to track of the max palindrome. And in the beginning, we need to declare two more variables to keep track of the max palindrome. Max center equal to 0, and also max right equal to 0. So these two variables are for the max palindrome, max length. And we don't keep track of the length, but we keep track of the center and the right boundary. Then we use these two values to calculate the length. So here, if length I is greater than max length, then we will update max center and the max right. This is the steps inside of the for loop, and for each character, it will process all these steps to find the palindrome with the longest length. After we find the longest palindrome, then we will return this palindrome. So here is end of the for loop. And we will return the substring, the position on the left, and the position on the right. On the right is the max right. And later we'll discuss the formula for the left. Now let's go through our pseudocode with an example. We're going to use the same example here. So at 0, and all these variables initialized with 0, and at 0 we cannot extend, so the length is 1, and all this remains at position 0. Now we move to the next character. It doesn't go anywhere, so it's 1. So here everything remains the same. We move again. And at C, we find a new palindrome is bounded from B to B. The length is 5. So here's 2. So now we found a new palindrome which boundary reaches to the most right. So the center is at 2 and the right boundary is at 4. It's also the longest palindrome we find so far. So max center is also 2, and the max right is 4. Then we move to the next character. And here we have A. Then we try to find the mirrored palindrome on the left side of the center. So the center is at position 2, C. So the mirror we find is here. So it has a length 1 and is contained. So we just copy the length to here. If we try to extend from the next character, which is B on the right side and the C on the left side, and it's guaranteed that they are not equal, so we can quickly move to the next character. So in the scenario here, the scenario number 2 will fail, and only scenario number 1 and the number 3 has opportunity to extend longer. This is where Moniker algorithm saves a lot of steps. So here is a key step. To save lots of work. And also, these steps also save a lot of work because it doesn't try to extend from the immediate character next to I, but try to extend from the character next to the palindrome already found. For example, here. So at the position 4, and we copy the length 1. And we cannot extend from B. Then we move to the next position. Now we come to D. Here, we can extend from D from A to A. So at 5, we find a new palindrome with a size of 9. Now we need to update all these 4 variables. Our new center is at 5, and the right boundary is at 9. The center for the max is 5, and the right boundary for the max is 9. We move again. So our new center is here. Okay, so we move to position 6. Its mirror is a B here. So it's 1, it is contained, and we cannot extend. We move to position 7. The length is 1, because we got a 1 from here. Cannot be extended. Okay, we move again to here. At the C, the mirrored character on the left side is C here. So it has a length of 5. But we cannot copy 5 to the position 8 because the palindrome on the left side is partially contained. So we have our boundary here. So the palindrome at the center C on the left side is partially contained. So we have to exclude the part outside of the boundary. So we have to exclude this. Then we can only use the palindrome inside of the boundary, which is from A to A. It has a length of 3. So we don't use 5 here, and we copy 3 here. And we have a formula to calculate the length inside of the boundary. So our boundary on the right side is here. Okay, now from 8, we try to extend from the next character of palindrome already found. Okay, so I have to make it clear here. So it's the next character of the palindrome found. All right. We found this palindrome and we try to extend from the next character here. So this character is not visited yet, but we know for sure it doesn't equal to B. So unfortunately, in this example, we cannot extend from C because the character on the left side is B and this character is not equal to B. So we cannot extend from C, but there is a possibility to extend longer from C. the length for the center C remains as 3. Okay, we stop our example here. Let's say that's all the characters we need to visit in this string. Then our palindrome with the longest length is centered at 5, and the boundary on the right side is 9. Okay, so here we find our longest palindrome. On the left side, its boundary is at 1. Now last, we will return the substring, which is the longest palindrome. So the left is 1, the right is 9.
This pseudocode gives you idea how does a Moniker algorithm work, but it only works for single-centered palindrome. I'll introduce a technique to make it also work for double-centered palindrome. We are going to wrap around each character in the string with a dummy character. For example, we have a string here. So in this string, we can find 2 palindromes from A to A and C to C. The first palindrome is double-centered at B, and the second palindrome has a single center at D. So for us to use one algorithm to find both palindrome, we can introduce dummy character between each character in the string. So we insert a pound sign here. And also at the end. So with our algorithm, the first palindrome we can find is from this pound sign to here. And it's centered at here. The length of this palindrome is 9. And the second palindrome we find is from here to here. The length is 7. When we return the palindrome by using the substring, we can simply divide the index by 2. For example, the left index we can divide by 2. The right index we can also divide by 2. In this example, the index on the left side boundary is 0. And the index on the right side boundary is 8. So when we return the substring, we return s.substring 0 divided by 2, 8 divided by 2. So it gives you the index on the left 0, index on the right 4. And remember, in Java, the substring doesn't include the character on the second index, so it will return the substring from 0 to 3. In our original string, we have A, B, B, A, and C is here. We specify 0 and 4 in the substring, and it will return from here to here. And it gives you the palindrome ABBA. So we are going to enhance our pseudocode to insert the pound sign between the characters of our input string. So here, insert dummy character between characters in string S. Next, we will change the meaning of the integer array len. For example, the palindrome centered at the D has a length of 9. When we use the length of the palindrome for our calculation of the index, we have to divide the 9 by 2 to get the distance from the center to the boundary. If we can keep the distance from the center to the boundary, then we don't have to divide by 2 every time. So we change the meaning of this integer array to distance from center to boundary for each card. So with this change, when we keep track of the distance, the numbers will be like this. Or the first character F, it doesn't expand to anywhere, so the character itself is a palindrome. Both center I and the right boundary pointing to the character itself. So the distance from the right side boundary to I is equal to 0. And same thing for letter A, and here is also 0. And at C, we found a palindrome from B to B. It has a length of 3. I is here, and the right side boundary is pointing to B. The distance from B to C is 1. It's only one character away. So for C, we will record 1. And here is 0. And the D, the distance from A to D is 4. Here is 0, 1, 0. With this change, we need to modify the code which assigns the initial value to the length. So in the first scenario, the length at I is no more 1, but it's 0. Okay, that's all the change we need to make for our pseudocode. Next, we'll go to the LeetCode website to implement for the Moniker algorithm. This is a pseudocode I prepared in the LeetCode website. So the first step will insert the pound sign between characters in the input string. After inserting the pound sign, we have the pound sign in the beginning of the string and the pound sign at the end of the string, and also the pound sign between the characters. So we are going to use a character array. The length will be string length times 2 and plus 1. For example, the length of our input string is 2, A and B. Then with our formula, the temp character array will be a length of 5. After we declare this character array, we're going to insert the pound sign into the array. So we have for loop here, and temp 2 times I equal to the character pound sign. And then at the position 2 times I plus 1 will assign the characters from the input string. And the next, we'll insert the pound sign at the end of the character string. So the next step is to track the distance from the center to the right boundary. To do that, we need to declare an integer array called the length. The next step is we need variables to keep track of the palindrome, which extends to the most right position. So we need 2 variables to keep track of the center of the palindrome and the right side boundary of the palindrome. And next, we need variables to keep track of the longest palindrome. We only need to track the center and also the right side boundary. Now, it comes to the part for the Moniker algorithm. First, we need a for loop to visit each character in the temp character array. Inside of the for loop, The first thing we do is to compare the position I with the right boundary. And here, based on the position of I, we have 3 scenarios. Then we will initialize the length at the position I with different value. So the code will be like this. We're going to have an if statement to compare I with the boundary. The variable right is the boundary of the palindrome reaches to the rightmost position. So here we're going to write one line of code to include all these 3 scenarios. So the distance at the position I equal to Next, we will extend the length of the palindrome from the character next to it. On the right side is I plus the distance plus 1. And on the left side is I minus the distance and minus 1. And we will try to expand from left and from right. So here, we'll have a while loop. We'll check if the character at this position on the right side equal to the character at this position on the left side. If they are equal, we'll increase the distance at the position I. And we'll also add 2 more conditions in the while loop because we want to make sure when expand to the left, it will stop when it reach to the beginning of the array. And also when extend to the right side, it will stop when it reach to the end of the array. So here, we'll check the first statement is for the right side. Make sure that it's smaller than the array's length. And the second statement is for extend to the left side. Make sure it's greater or equal to 0. This is the code to extend the palindrome. The next step is, if our palindrome grows outside of the boundaries, we will update the center and the right boundary. Remember the definition of our center and the right. It tracks the palindrome which extends to the most right position. So if it grows outside of the boundary, then we have to shift the center and the right boundary to the right. If I plus len at the position I greater than right boundary, then we will update the center equal to I, and then update the right side boundary equal to I plus the distance. Next step is, if the palindrome we find has a length longer than the longest palindrome we found before, then we will update these 2 variables with the new palindrome. Here we'll have an if statement. If len at the position I is greater than the len specified by the max center, then we will update the max center equal to I, and the max right equal to I plus the distance at the position I. Okay, so these are the steps in the for loop for the Moniker algorithm. We need to return the palindrome. This is the implementation based on our pseudo code, so let's test it. So the test is successful. Now let's submit our code. The submission was successful. The runtime is 9 milliseconds and is faster than 97% of all the online submissions. So our Moniker solution has runtime 9 milliseconds. And the ranking is 97%. So it's faster than 97 of all the online submissions. And compared to our first solution, the runtime is reduced dramatically from 23 milliseconds to 9 milliseconds. And the reason the Moniker algorithm works better is because it's a big O(n) time complexity. Now let me explain why does the Moniker algorithm has a big O(n) time complexity. And remember, in our LeetCode implementation, when we expand the palindrome, we also use a while loop inside of the for loop. The trick is in these three scenarios, because with the Moniker algorithm, it only tries to extend the palindrome from the outside of the boundary. For example, we have found this palindrome from A to A. Then, when we move the pointer away from D, if the palindrome we found is contained by this bigger palindrome, then it's a scenario number 2. It always fails. So it never tries to extend from B or from C or from D. Only when it comes to the edge, then it has a chance to expand the palindrome again. So when we move from the left to right, we stop here. Then we will continue to expand from here, then move to the right. So there's no overlapping between our search. So that's why Moniker algorithm has a runtime complexity big O(n). Alright, that's all for the LeetCode problems number 5. We end our discussion here. Thank you for watching.